Hey everyone, welcome back to Learn with me. So today we're going to be diving into the wonderful world of neurons. They're the fundamental building blocks of our nervous system, and understanding how these incredible cells work will help us understand the basics of behavior and mental processes, which is important for your AP exam. So we're going to explore the structure and function of typical neurons, and we're going to see how they impact everything we do. So I'm going to go along with the slideshow. So I'm going to give you some background information and things like that. If you want to see the entire slideshow, you can go to the link below and get it from my Teacher Pay Teacher store. And if you really find this video helpful, please hit the like button and subscribe to my channel. Here we go. Okay, so let's dive into 1.3, the neuron and neural firing. So first of all, we need to look at the CED question. We know that these are put out by the College Board because this is what they're basing the exam on. So it's really important to go through the CED and to understand each of these questions and be able to answer them. So we're going to look at the first one. There's 3 in this particular section. Explain how the structures and functions of typical neurons in the central nervous system affect behavior and mental processes. Okay, so we're going to look at that in depth. Okay, first of all, here's the key terms for this particular unit. I'm going to do a separate video on these where I'm going to tell you the definition and real life examples. Super important to keep these flashcards going. You know, you have your word, you have your real life example, because it's important to understand each of these terms so that you can apply them on test day. Okay, let's look at the structures of neurons. So we're going to look at the basic parts of a neuron: the cell body, also known as the soma, the dendrites, the axon, and axon terminals. And I have a little graphic here we can look at while we're talking about these. So let's start with the cell body, or the soma. So that's up here. It says contains the cell nucleus here. The cell body is like the neuron's headquarters. It contains the nucleus and other organelles that keep the neuron alive and functioning. This part integrates incoming signals from the dendrites and decides whether it's going to send that signal down to the axon. Let's look at the dendrites. See, it says receive signals from other neuron cells. So dendrites are the branching extensions that receive signals from other neurons or sensory receptors. They play a key role in determining how a neuron responds to incoming information. So the more dendritic connections a neuron has, the more signals it can receive and process. And you can remember the dendrites as these little branches here on the parts in the neuron. Let's look at the axon. That's just here, and a little message here says conducts electrical impulses along the neural cells. What does that mean? The axon is a long fiber that carries electrical impulses away from the cell body to other neurons, muscles, or glands. Many axons are covered in a myelin sheath, which acts like insulation and spreads up the signal transmission. Axon terminals. At the end of the axon, we have the axon terminals. You can see it's like the other end of the branch. You got the branches up here, you got the branches down here. So you got to remember that when you're thinking of picturing that neuron in your mind. At the end of the axon, we have the axon terminals. These terminals release neurotransmitters, which are chemical messengers that travel across the synapse, which is the gap between the neurons, to communicate with the other cells. Okay. Now we're going to look at the function of neurons and their impact on behavior and mental processes. So we're going to start with looking at signal transmission, then information processing, neurotransmission and synaptic communication, and plasticity and adaptation. Let's start with signal transmission. Okay, so this is how the neurons communicate. They talk to each other. Neurons transmit electrochemical signals known as action potentials. Remember, all these keywords are going to be in my keyword video. These signals travel along the axon and reach the axon terminals, where neurotransmitters are then released. The speed and efficiency of these transmissions are really important for our reaction times, our motor coordination, and sensory perception. Neurons don't work alone. They're part of this complex network and circuits in the brain and spinal cord to process information and coordinate our responses. Then we have information processing. Neurons integrate signals from multiple dendrites. The integration is essential for complex processes like decision-making and problem-solving. neurotransmissions, and synaptic communication. So different neurotransmitters influence the behavior and mental processes in very unique ways. So for example, serotonin will affect our mood. Dopamine is basically involved in that reward and motivation, and acetylcholine is crucial for memory and muscle movement. So different jobs, different actions. Brain plasticity and adaptation. This plasticity includes synaptic plasticity, like long-term potentiation, we call it LTP, and long-term depression, LTD, which are key for learning and memory. Structural plasticity involves a change in dendritic branching and synapse information, which can then affect our cognitive abilities. Okay. We're going to look at the impact on behavior and mental processing. Oh, right. Sorry about that. Okay, so let's look at that. So let's look at some specific functions of a neuron in the different brain areas. Okay, so we're going to look at motor function, sensory processing, emotional regulation, cognition and higher mental processes, and memory formation. Let's start with motor function. So the neurons in the motor cortex and the spinal cord control voluntary movement. So if there's damage here, we know that this can affect our motor skills. Sensory processing, neurons in this sensory area, like the visual and auditory cortex, interpret sensory inputs and they shape how we perceive things. They shape our perception. Emotional regulation, this is the neurons in the limbic system. This includes the amygdala and the hippocampus, and neurotransmitters like serotonin and dopamine, which we talked about earlier, play significant roles in our emotional responses and mood regulation. Cognition and higher mental processes. Neurons in the prefrontal cortex and other association areas are vital for those higher functions, like, for example, reasoning, decision-making, problem solving. Then we look at memory formation. The hippocampus, when we think memory, we think hippocampus, and other regions are crucial for encoding, storing, and retrieving memories. Neurons are the foundation of everything we do, feel, and think, from simple reflexes to complex cognitive processes. They shape our behavior and our mental experiences, and understanding how these neurons function will help us look at valuable insights into psychology and neurosciences. Okay, so now let's look at the second CED question in 1.3. Explain how the basic process of neural transmission is related to behavior and mental processes. Okay, so to understand neural transmission, we need to understand how neurons communicate. So neurons use both electrical and chemical signals to send messages. So let's break that down. So we're going to start off with signal transmission and information processing. We're going to look at action potential, threshold excitability, and behavioral implications. I've actually added the little graphic that we used in the first question, just so you can follow along as to where we're talking about. Okay, so let's go. Neural transmission kicks off with action potential, an electrical impulse that travels down a neuron's axon. Think of it as an electrical signal racing along a wire. But before that, neurons receive inputs from other neurons through the dendrites. When these inputs reach a certain threshold, they trigger the action potential. This process is very important in deciding when the neurons should fire. The speed and efficiency of these signals affects everything from our reaction times to our motor skills. So for example, a quick signal transmission is key for fast reflexes. So for example, if you're trying to pull your hand away from something that's hot. Okay, the next one we're going to look at. So once the action potential reaches the end of the neuron or the axon terminals, it's time for the next step, the synaptic transmission. At the synapse, which is the space between the neurons, the action potential triggers the release of chemicals called neurotransmitters. These molecules cause the synaptic cleft and bind to the receptors on the next neuron, passing along the signal. Neurotransmitters can either excite or inhibit the next neuron, determining whether it will fire an action potential. Different neurotransmitters have different effects. So for example, dopamine is linked to motivation and reward. Serotonin affects mood, and acetylcholine is involved in memory and muscle movement. Problems with these systems can lead to disorders, for example, like depression or Parkinson's disease. Okay. Neurons, they don't work alone, okay? They're part of a complex circuit of networks in the brain and spinal cord. So neural circuits integrate and process information from various sources. This is where our cognitive functions like attention, memory, and decision-making come into play. So for example, the amygdala, which is part of the circuit involved in fear response, while the prefrontal cortex is crucial for planning and making decisions. These circuits shape our behaviors based on the information they process. One of the most amazing features of our nervous system is its plasticity, its ability to change and adapt. Neural plasticity involves change in the strength of the synaptic connections and the growth of pruning of the dendrites. The adaptability is essential for learning new skills, forming memories, and recovering from injuries. So for instance, repeated practice strengthens certain neural pathways, helping us get better at a skill. Hence the little saying we say, practice makes perfect. Lastly, let's talk about the broader role of neurotransmitter systems in our emotions and behaviors. Neurotransmitters like serotonin, dopamine, and norepinephrine. I'm really having a hard time today. Sorry, guys. Norepinephrine play key roles in regulating our emotions, stress response, and overall mood. For example, imbalances in these three systems can lead to mood disorders like depression or anxiety, and understanding these systems can help us develop treatments for such conditions. Okay, so just to wrap it up and summarize a little bit, the process of neural transmission from action potential and synaptic transmission to neural circuits and plasticity. It's the heart of all our behaviors and mental processes. It's basically how our brains make sense of the world and how we respond to it. So that was question number 2. Let's move on to the third question in 1.3. So now we're going to look at the third CED question, explain how psychoactive drugs affect behavior and mental processes. Okay. This particular section has lots of vocabulary that were not sort of related directly to the first and second question. So I'm going to put them onto the key terms video as well with a definition and real life example to help you be able to make your flashcards and to have a better understanding of that vocabulary. Okay, so first up, we have stimulants. So these include cocaine, amphetamines, but what exactly do stimulants do? So what are the effects? So one of the effects would be increased alertness and energy. So it produces that feeling of alertness, increased energy, reduced fatigue. Another one would be elevated mood. They often produce or induce this feeling of euphoria, feelings of pleasure. The other one would be improved focus. Stimulants can enhance concentration and cognitive performances in the short term, and appetite suppression. Some stimulants reduce appetite, which can lead to weight loss. But what are the behavioral implications of stimulants? Well, abuse of stimulants can lead to addiction, erratic behavior, aggression, and potentially harmful physical effects such as cardiovascular issues. Next, let's talk about depressants such as alcohol and benzodiazepines. So what are the effects of those? So we have sedation and relaxation, which basically means that depressants induce feelings of relaxation and calmness, reduced anxiety. They can alleviate anxiety symptoms due to their calming effect. Impaired judgment and coordination. Depressants can impair motor coordination, cognitive functions, and decision-making skills, and memory impairment. Heavy use of depressants can lead to memory problems and blackouts. So what are the behavioral implications? Well, excessive use of depressants can result in addiction, impaired driving ability, accidents, and overdose. Now onto opioids like heroin and morphine. So what are the effects of opioids? So first of all, pain relief. Opioids are highly effective in relieving pain because of their pain-killing properties. Euphoria, they can induce this feeling of happiness and well-being. Sedation, opioids are often cause drowsiness and sedation. So what are the behavioral implications of opioids? Opioids can lead to physical dependence, addiction, respiratory depression, overdose, and often very serious health risks. Okay, now onto hallucinogens like LSD and psilocybin. This takes us into the realm of altered perceptions, and some of the effects of hallucinogens can be hallucinations. So hallucinations can cause profound alterations in sensory perception. It can lead to visual, auditory, and tactile hallucinations. Altered consciousness, they can induce a sense of detachment from reality, a dissociation, or altered states of consciousness. And mood enhancements. Some hallucinogens, for example, like MDMA, which we know as ecstasy, can produce feelings of empathy and emotional openness. So what are the behavioral implications of hallucinogens? Well, hallucinogens can lead to unpredictable behavior, impaired judgment, and in some cases, persistent psychosis and flashbacks. So lastly, let's discuss cannabis, also known as marijuana. So what are the effects of cannabis? So first of all, euphoria. So cannabis can induce feelings of relaxation, euphoria, happiness, altered sensory perception. It can also enhance appetite. It's often referred to as the munchies. Cannabis can increase appetite. Also, impaired memory and cognition. So, heavy cannabis use can impair short term memory and cognitive functions. And what are the behavioral implications of cannabis? Well, chronic use of cannabis can lead to dependence, reduced motivation, impaired academic or job performance, and potential long term cognitive effects, especially in adolescence. So, what does this all mean for behavior and mental processes? Well, psychoactive drugs can lead to addiction, impaired judgment, and cause mood swings. They also affect cognitive functions like memory and decision making. So, understanding these effects help us address substance abuse and develop better treatments. That's a wrap on our exploration of psychotic drugs. Remember, while these substances can alter our brains in fascinating ways, they also carry many risks. So that's all you need to know for 1.3, the neuron and neural firing. And remember, if you want to know the key terms for your flashcards, I'm going to make a separate video for all the key terms related to 1.3. Thanks for listening. If you found this video helpful, please don't forget to like, share, and subscribe to our channel for more AP psychology content. Check out the link below also to my Teacher Pay Teacher store for the full slideshow and workbook. See you next time.